If you're running vibration or dynamic simulations in Abaqus, the very first thing you need to know is the natural frequency of your structure. In the next few minutes, I'll show you exactly how to determine natural frequency using Abaqus, step by step with a sample modal analysis example. We'll go through the setup, boundary conditions, how to interpret the mode shapes without unnecessary theory. By the end, you'll know how to confidently run and understand a natural frequency analysis in Abaqus. Let's get started. Create part, should be 3D deformable solid extrusion, and put this one on 300 and continue. Let's create a rectangle like this. This should be somewhere around like 10, 150, and this can be 30. And this is the plate we have. And let's go to the property. We create a material property. This should be pretty simple. General density 7.8 E minus 9. And from mechanical elasticity and elastic, this should be 210 E3 and 0.33. The units are in SI millimetric. Click on OK. Now we need to create a section. Section 1 solid homogeneous, and material is material 1. We assign this section to this one using assign section. Uncheck this one because you don't want to have too many sets. And OK, as it turns green, it means the property is assigned. Now it's time to go to assemble the model. Create instance, part 1, and OK, easy as that, the model is assembled. As always, I like to translate this one. Using this one, you can rotate it, press escape, so you can translate it here to make things easier. Then we reset the view and we go to the step. Now here we create a step, but unlike other times, we don't want to have general, static general, or maybe dynamic explicit, but this time we want to click here, and instead of general, we want to have linear perturbation. So we click here, we can have buckle, frequency, static, linear, but we want to have frequency this time, because we want to take a look at the natural frequencies. Here we have two options. Pay attention. We can either have the number of natural frequencies here by inputting a value, for instance 5. We would have the first 5 natural frequencies of this steel. But if I want to have the cycle, we can have a minimum requested cycle, or we can have a maximum cycle, and Abaqus automatically determine the natural frequencies between the ranges. I would like to put it on 6, and we don't need anything here, and OK, and that's all. Now we need to go to the load and boundary condition, and here the load and boundary conditions is also easy. So from here I want to create a new boundary condition, step initial, and from mechanical we select this one because I want to encast the other side. You can rotate it using this tool, then you can select here, done, and encast. We close all of the degrees of freedom for this one, and that's all for loads and boundary condition. And let's go to the mesh. We have to go to the part, and let's see the part. We can have like a number of 2 to have a very accurate mesh here, and mesh it like this, and that's also finished. We are good to create a job. I would like to name a job natural frequencies, and done. Now we need to submit the job. While we're waiting for the job to be completed, I want to ask you a favor. If you enjoyed this video so far, please leave a comment for me. That's free for you, but it helps me a lot to grow. Thank you very much. And yeah, as you can see, the job is completed. And if you want to take a look at the results, you can have the animate history. This is very fast. Let's put it on slow. It shows different natural frequencies at a time, but there's a way to see one at a time. To see and compare different natural frequencies, you have to go to the results and you have to select step/frame. And here you have different natural frequencies. Let me zoom out this one. And here we have the first natural frequency, second, third, fourth, fifth, and sixth. So the first one happened at 367th cycle. You can double click on it, or if you can double click on the next one, this one, this one, this one, and this one. So if I select this one and if I want to compare it with the other one, there's a way for it. So first I want to go to the option, comment, and feature edges and click on OK. In this case, it is better. And if I want to compare them, I need to go to the viewport and create. I do this a couple of times. And viewport, now tile horizontally. And as you see here, we have 4 different tabs, but it's not ready yet. So this one is activate now. Now we go to this one. We go to the results, step, frame, and put this one on the second and click on OK. Now I need to select this one, again result, step. I can put this one on the third, and I select this one. I go to result, step frame, and I put it on the fourth. You can get rid of the contour if you want to, if you just want to take a look at the shape. So to do that, first I want to go to viewport and link all viewports. So in this case, if I click on this one, it would happen for all of them. And then we go to viewport and viewport annotation option, and in this one you can set all off. And as you see here, we only have the contours. Then you can compare different frequency shapes, like this is the first one, this is the second one, this is the third one, and this is the fourth. And that would be all for today. If you want to learn other mechanical testing methods, click on the video on screen before it ends, and I see you there. Stay tuned.